A 4,500-year-old stone structure holds mathematical secrets it should not possibly know. The Great Pyramid of Giza was engineered with a precision that seems to defy its era. A leading Egyptologist once described it as a message in stone from a forgotten age of science. This presents us with a single, haunting question. Was this incredible accuracy a miraculous coincidence, or the product of a lost, advanced design? In this exploration, you will uncover the evidence that allows you to answer that question for yourself. We will investigate how the pyramid's very shape encodes fundamental constants and how its placement mirrors the heavens. By the end, you will be able to decide if you are looking at history's greatest accident or its most carefully guarded secret. What does true genius from the ancient world actually look like? Standing on the Giza Plateau over 4,500 years ago, the scene would have been almost beyond comprehension. Without the wheel, iron tools, or modern machinery, a civilization orchestrated the movement of millions of stone blocks, each one weighing multiple tons. This was not merely a construction project, it was a monumental act of will that reshaped the very landscape. The sheer scale of human effort involved, the thousands of lives dedicated for decades, points to something far beyond a simple tomb. It suggests a purpose of profound significance, executed with a level of planning that makes the idea of random chance feel deeply inadequate. How could such a vast undertaking, requiring such precise coordination, result in accidental perfection? The answer begins with the raw numbers themselves, the fundamental measurements that have survived the ages. The original height of the Great Pyramid was 481 feet, with a base perimeter measuring 3,024 feet. These figures are not just dimensions, they are the foundational data set, the undeniable facts upon which every theory is built. When you look at these numbers, you are not just seeing the size of a building, you are looking at the primary evidence in an ancient mystery. The immense labor and staggering organization required to achieve even these basic forms alone forces us to question the nature of the builders' knowledge. They clearly possessed a masterful understanding of logistics and engineering, so why would we assume their mathematical insight stopped there? This foundational understanding of the pyramid's physical reality is the crucial first step, the solid ground from which we can begin to unpack the incredible encodings hidden in its very shape. The raw numbers of the pyramid's dimensions hide a startling mathematical secret. If you take the pyramid's base perimeter and divide it by twice its original height, the result is a figure incredibly close to the mathematical constant pi. Specifically, the perimeter of 3,024 feet divided by twice the height of 481 feet gives you a value of approximately 3.141. This is remarkably near to the true value of pi, the ratio of a circle's circumference to its diameter, a number not formally defined in the Western world for another 2,000 years. In the 19th century, a mathematician and publisher named John Taylor became captivated by this relationship. He argued it was no accident, proposing that the pyramid's architects intentionally designed this ratio into the very fabric of the structure as a form of encoded knowledge. This idea forces a profound question. Did the builders choose their slope angle specifically to embed this fundamental constant of the universe into stone, perhaps to symbolize the cycles of nature and the celestial spheres? Or was this pi relationship merely an unintended byproduct of a construction method that used a simple, repetitive sect or slope angle that just happened to produce this elegant result? The implication is staggering. It suggests the pyramid could be read not just as a tomb, but as a silent mathematical treatise, a deliberate fusion of geometry and stone. And if one fundamental constant was embedded so precisely, could there be another, even more profound connection waiting to be uncovered? This same sense of encoded knowledge extends to a second mathematical marvel, one that governs the very patterns of life itself. The golden ratio, approximately 1.618, appears throughout the natural world, from the elegant spiral of a nautilus shell to the vast arms of a galaxy. It is a universal constant of beauty and proportion, and it seems to be written directly into the Great Pyramid's geometry. Art historians often point to its use in classical aesthetics, a principle of harmony that cultures have returned to again and again. But here it is, millennia earlier, in the very shape of this ancient wonder. The relationship appears when you examine the pyramid's triangular cross-section. The ratio of its apothem, the diagonal line from the tip down to the center of a base side to half of its base length, gives a value extraordinarily close to phi. This is not a random number, it is a fundamental principle of optimal growth and structural balance. So, did the pyramid's architects intentionally design this ratio into their work, valuing it for its inherent, almost sacred harmony? Or is this, like the appearance of pi, another breathtaking coincidence? The presence of phi suggests the builders may have possessed an understanding that went far beyond simple construction, tapping into the deep mathematical laws that shape our reality. If they were encoding these universal constants, then perhaps the entire structure was conceived as a model of the cosmos itself, a thought that pulls our gaze from the geometry of the pyramid's face to its placement on the Earth. The mathematical constants hidden in the pyramid's shape are only part of the story, for its physical placement on the Earth is a marvel in itself. Under the pristine darkness of an ancient Egyptian night, far from the light of modern cities, the stars would have blazed with a clarity we can scarcely comprehend. It was in this obsidian canvas that priest astronomers performed a task of monumental difficulty, meticulously tracking the slow wheeling of the heavens to pinpoint true north. Their success is etched into the very foundations of the Great Pyramid. The four sides of its colossal base are aligned to the four cardinal directions with an accuracy of within 1/15th of a single degree. To appreciate this, consider that the pyramid's base covers an area of over 13 acres. The precision required to keep such a vast structure perfectly square and oriented over a construction period spanning decades is almost beyond belief. Modern surveyors and archaeologists who have measured this alignment express a shared sense of astonishment. They note that achieving such accuracy with simple tools would be a formidable challenge even today. So how was it done? One compelling theory points to the simultaneous transit method. This would involve an observer sighting on two stars that circle the north celestial pole, like Kochab and Mizar in the bowl of the Little Dipper. By marking where one star rose and the other set on the horizon, and then bisecting that angle, they could find a line pointing directly to true north. This was not merely a technical exercise. For the ancient Egyptians, the cosmos was a divine map, aligning the pyramid with the cardinal directions, with the immutable poles of the sky, was to anchor the pharaoh's eternal resting place within the eternal order of the universe. It was a crucial step in his journey to the afterlife, ensuring his spirit could navigate the celestial river as seamlessly as the stars themselves. This incredible directional accuracy, a testament to profound astronomical knowledge, forces our investigation to look upward, to see if the pyramid's connection to the heavens is even more literal than we first supposed. These narrow shafts, often called air shafts, were far more than simple ventilation. They were precisely engineered corridors of stone, piercing the pyramid's massive core to point like celestial arrows at specific stars. From the king's chamber, one shaft targeted the star Al-Nitak, the brightest star in Orion's belt. Another was aligned with the star we know as Thuban, which was the pole star of that ancient era. The Queen's chamber shafts reached for the brilliant star Sirius, sacred to the goddess Isis, and the same constellation of Orion. This was not a random assortment. For the ancient Egyptians, the constellation Orion was the celestial representation of Osiris, the god of the afterlife and rebirth. To align the pharaoh's eternal pathway with these specific deities was to weave his soul directly into the cosmic order, ensuring his divine resurrection. This profound celestial connection gave rise to one of the most compelling and debated theories in modern Egyptology, the Orion correlation theory proposed by author Robert Bovell. He suggested that the entire Giza Plateau was a terrestrial map of the night sky. Bovell argued that the three great pyramids of Giza were intentionally arranged to mirror the three stars of Orion's belt, with the Nile River symbolizing the Milky Way. The match, when projected back in time, is visually striking. This theory hinges on a critical astronomical phenomenon known as precession. Earth's axis slowly wobbles over a cycle of approximately 26,000 years, much like a spinning top. This gradual shift changes our view of the stars over centuries. When we account for this precessional drift and rewind the sky to the estimated date of the pyramid's construction, the alignment Bovell proposes appears to lock into place. Mainstream Egyptology, however, offers significant counter-arguments. Many scholars point out that while the shaft alignments are undeniable, the grander pyramid layout matching Orion's belt is less precise. They note that the archaeological record provides no direct textual evidence that the ancient Egyptians conceived of such a massive star map project. The argument is that the visual correlation, while fascinating, could be a product of coincidence amplified by our modern desire to find patterns in the past. This scholarly debate highlights the central mystery. Was Giza the product of a single, sophisticated long-term astronomical plan, a stone blueprint of the heavens intended to last for eternity? Or are we witnessing the incredible but ultimately coincidental convergence of a culture's spiritual beliefs and their architectural prowess? If this celestial mapping was intentional, it reveals a civilization thinking not just in generations, but in millennia, planning a monument that would remain in dialogue with the cosmos long after their names were forgotten. This idea of the pyramid as a global landmark becomes even more powerful when we consider its physical relationship to the Earth itself. Beyond its celestial alignments, the Great Pyramid's dimensions suggest a purpose that encompasses the entire planet. Its architects may have been thinking on a truly global scale, designing the structure as a reduced model of the Earth itself. This astonishing idea hinges on a single, precise measurement. The pyramid's original base perimeter was 3,024 feet. If you multiply this perimeter by 43,200, a significant number in ancient timekeeping, the result is almost exactly the length of the Earth's equatorial circumference. The match is staggeringly close. This is not the only geodetic relationship. The pyramid's height multiplied by the same number, 43,200, gives a figure remarkably near the Earth's polar radius. These are not abstract numbers. They represent the fundamental dimensions of our world, seemingly scaled down and locked into the pyramid stone. In the 19th century, this connection captivated an astronomer named Charles Piazzi Smyth. He devoted his life to measuring the pyramid and became convinced it was a divine revelation in stone, a repository of God-given geodetic knowledge meant to preserve the Earth's true measurements for all time. Smyth's passionate belief, however, stands in stark contrast to the skepticism of the modern scientific community. Critics point out that the ancient Egyptians left no written records suggesting they knew the Earth was a sphere, let alone its precise circumference. They argue that the mathematical elegance of these correlations could be a product of the particular unit of measurement we choose to use, the pyramid cubit, and the sheer number of possible mathematical combinations one can test against a structure with so many dimensions. The statistical probability of such a perfect match occurring by chance is incredibly slim, yet not impossible, so we are left with a profound puzzle. Did a civilization from the dawn of history somehow possess an advanced understanding of global geography, encoding the very shape of the world into a single, magnificent building? Or are we, centuries later, simply seeing patterns we are predisposed to find, connecting dots across millennia in a way that makes poetic sense to us? To answer that, we must look more closely at the very ruler they used, the building block of all these measurements, for the secret may not be in the number itself, but in the unit that created it. The royal cubit was far more than a wooden stick for marking lengths. It was the fundamental building block of the entire pyramid, the unit that translated abstract architectural plans into monumental reality. This sacred measure, approximately 20.62 inches long, was the standard used by every foreman and craftsman on the Giza Plateau. But where did this precise length come from? Some researchers propose a breathtaking origin, suggesting the cubit was not arbitrarily chosen, but was instead derived from the dimensions of the Earth itself. The theory posits that the royal cubit represents 1/10,000,000th of the Earth's polar radius. Think of that, a unit of measure used to build a single structure, potentially scaled from the entire planet. Metrologists, scholars who specialize in ancient measurement systems, are deeply divided on this idea. Some see a local, practical tool, perfected over generations for royal construction projects. They argue the cubit was a brilliantly standardized unit for its time, but a local one nonetheless. Others, however, look at the global evidence, noting similar units of measure appearing in ancient cultures separated by vast oceans, and wonder if a forgotten, universal standard once existed. The elegance of using the cubit becomes clear when you see the pyramid's core dimensions. Its base side length was designed to be precisely 440 royal cubits, and its original height 280 royal cubits. These are clean, whole numbers. For the architects, this meant that the most complex geometrical calculations for slope, angles, and volumes could be managed with simple, repeatable ratios, avoiding fractions and simplifying the immense logistical challenge. This practical benefit is undeniable, but if the cubit itself was a geodetic measurement, a fragment of the world's size, then the pyramid's design shifts from being merely brilliant to being cosmically self-referential. It would be a structure built with a unit of the Earth, scaled to model the Earth, and aligned with the heavens above the Earth. Critics of this grand view offer a necessary counterpoint. They remind us that correlation is not causation. With a structure as vast and numerically rich as the Great Pyramid, it is statistically probable that we can find many seemingly significant mathematical relationships if we look hard enough. They argue that the human mind is a pattern recognition engine, and we may be connecting dots that the original builders never intended to link. So, was the royal cubit a remarkable but local standard, or a lost key to planetary dimensions? The answer you lean towards will fundamentally shape your view of an ancient civilization's true reach, and force a final, unavoidable question about the line between a miracle of coincidence and a whisper of lost knowledge. Yet for every grand theory of encoded knowledge, a powerful counter-argument emerges from the halls of modern scholarship. Picture a quiet university office where a researcher carefully applies a principle known as Occam's razor. This is the philosophical idea that among competing explanations, the one with the fewest assumptions is usually correct. From this perspective, the pyramid's mathematical marvels begin to look less like deliberate design and more like the inevitable outcome of pattern recognition. Skeptics point out that with a structure possessing so many measurements and angles, it is statistically almost certain that some will, by pure chance, align with important constants. The sheer number of possible relationships means we are bound to find a few that seem astonishingly significant, especially when we have the freedom to interpret measurements slightly or use specific units that make the numbers work. This is not to diminish the pyramid's achievements, but to ground them in a different kind of reality. Prominent Egyptologists like Mark Lehner, who has spent decades excavating at Giza, argue that we must interpret the pyramid through the lens of what we know from other Egyptian texts and artifacts. The evidence points to a culture deeply concerned with practical engineering, state-sponsored religion, and powerful symbolism, but not necessarily with encoding advanced mathematics for the future. Take the appearance of pi, for instance. This relationship can be elegantly explained by a simple construction method the Egyptians actually used called a seek. This was their unit for measuring slope. If a builder chose a specific, round-numbered seeked, the resulting pyramid would automatically embody the pi ratio as a natural byproduct of its geometry. There was no need to know the constant pi itself. They simply needed to consistently apply their own practical slope measurement. The same logic applies to other correlations. Could the alignment with the golden ratio simply be the most stable and aesthetically pleasing angle for a pile of stone so immense? Might the geodetic relationships be a fortunate coincidence of a well-chosen local measurement unit, the royal cubit, rather than proof of a global survey? This skeptical view challenges us to find stronger, irrefutable evidence for intentional design. It asks us to consider whether we are projecting our own modern fascination with mathematics onto an ancient masterpiece whose true meaning was rooted in something else entirely, the profound and very human desire to build a gateway to the gods that would stand forever. The sheer number of precise relationships converging in one place defies easy dismissal. When you step back and view the evidence as a whole, the case for coincidence begins to strain under its own weight. It is not merely the presence of pi, or the appearance of the golden ratio, or the celestial alignments alone. It is the fact that all of these profound mathematical and astronomical constants are woven together into the very fabric of a single, coherent structure. Proponents of the design theory argue this is a statistical improbability of monumental scale. To believe it is all accidental is to accept that a culture achieved a near-perfect alignment to true north, intentionally built shafts to specific stars, and employed a slope that just happened to produce two of the most important constants in mathematics, all without any of these elements being part of a conscious, unified plan. The odds of that are astronomically low. Modern engineers who study the construction are often the first to point out the implications of such precision. Achieving this level of accuracy across a project of this magnitude is not something that happens by guesswork. It requires a master plan, a deep and working knowledge of geometry and ratios, and a system of quality control that could ensure these meticulous standards were repeated millions of times over decades of labor. The pyramid does not feel like a happy accident. It feels like the execution of a brilliant, intellectual blueprint. The mathematical themes are too consistent, too elegantly interlinked to be anything but deliberate. This unified design points toward a mind of staggering capability, a master architect who conceived of a structure that was at once a tomb, an observatory, and a mathematical model of the world. Who was this individual, and what forgotten school of thought did they represent? The Rhind Mathematical Papyrus, a 4,000-year-old textbook, reveals the mind of an Egyptian mathematician at work. Its carefully inked problems demonstrate a solid grasp of arithmetic, fractions, and practical geometry, showing how to calculate the slope of a pyramid side or the area of a field. This is the knowledge we can confidently attribute to them, the kind taught in scribble schools and used for administering a kingdom. Yet when we hold this documented knowledge against the Great Pyramid's precision, a puzzling gap emerges. The papyrus shows a culture brilliant at solving earthly problems, but it contains no mention of pi, no theorems on the golden ratio, and no complex formulas for celestial mechanics. So how did they build a structure that seems to embody these very concepts? This is the central tension at the heart of the mystery. Did the pyramid's architects operate with a secret, more advanced understanding, a kind of master knowledge reserved for the most sacred royal projects and never committed to common papyrus? Or does the pyramid itself represent the absolute peak of their applied science, a culminating achievement that simply outstripped the need for written explanation? Historians are divided on this point. Some argue that what we see in the pyramid is the natural extension of known Egyptian techniques, perfected on a monumental scale. They suggest that practical experience with ramps, sledges, and surveying ropes, refined over generations, could account for the accuracy without requiring hidden mathematical secrets. Other scholars look at the same evidence and see something more. They point out that the precision of the cardinal alignment alone suggests a method of astronomy not recorded elsewhere. The convergence of so many mathematical constants in one design feels intentional, pointing to a conceptual leap that has left no other trace in the archaeological record. This debate forces a difficult question. Are we underestimating the sheer innovative power of the ancient Egyptian state, its ability to synthesize and execute a project of unimaginable complexity using only the tools we know they had? Or does the Great Pyramid stand as a silent witness to a lost chapter in human knowledge, a school of thought that flourished in stone but vanished from history, leaving behind only this colossal, enigmatic message? When faced with an artifact that seems to defy its own time, the human imagination naturally reaches for extraordinary explanations. This is the territory of lost civilizations and ancient visitors, ideas that have captivated millions through books and documentaries. Authors like Erich von Däniken proposed that the pyramid's precision is not a human achievement at all, but the work of extraterrestrial beings who shared advanced technology with early cultures. In this view, the structure becomes a kind of landing beacon or message for future generations, built with knowledge that humanity was not yet ready to discover on its own. Other theorists suggest a different source, a now vanished advanced society such as Atlantis, whose survivors supposedly guided the Egyptians. These narratives are compelling because they offer a clean, dramatic answer to a deeply puzzling mystery. They resolve the tension between the pyramid's sophistication and the known capabilities of its builders by introducing an external, superior intelligence. However, when we examine these ideas through the lens of empirical science and archaeology, they encounter significant hurdles. Mainstream critics point to a complete absence of physical evidence, whether in the form of advanced tools, anomalous materials, or corroborating records that would support such intervention. The theories often rely on interpreting mythological texts as literal history, a method most scholars find unreliable. Furthermore, they can inadvertently diminish the genuine or inspiring ingenuity of the ancient Egyptians themselves, reducing a monumental human accomplishment to a passive reception of outside help. Yet, the enduring popularity of these speculations is itself a powerful piece of data. It tells us that the Great Pyramid, in its silent, mathematical perfection, creates a cognitive gap that some feel can only be bridged by a leap of faith. It speaks to a deep-seated desire for our past to be even more mysterious and wondrous than it already is. As we near the end of our investigation, we are left to weigh all the evidence from the grounded to the galactic and decide what we are truly looking at. Perhaps we have been searching for the wrong kind of blueprint. To truly understand the pyramid's precision, we must step into the minds of its creators, a world where the line between a mathematical equation and a prayer was vanishingly thin. For the ancient Egyptians, the universe was governed by a divine principle known as Mot. This was not merely a concept of truth or justice, but the very embodiment of cosmic order, balance, and harmony. It was the force that kept the stars on their paths, the Nile flooding its banks, and the sun rising each morning. In this worldview, chaos was the ultimate enemy, and the role of the pharaoh was to uphold Mot through his rule and, crucially, through his death and rebirth. The pyramid was his ultimate tool in this eternal struggle. It was not a tomb in our modern sense of a final resting place, but a resonant machine, a device engineered to channel cosmic energies and facilitate the king's transformation into a star god. Every aspect of its design served this sacred function. The meticulous alignment to true north was not just a surveying feat. It was about anchoring the structure to the still, eternal axis of the sky, the one fixed point in the turning cosmos. The star shafts were not simple air vents. They were celestial conduits designed to funnel the soul of the pharaoh directly toward the specific astral deities who would grant him eternal life. In this context, mathematical precision becomes a form of religious devotion. A perfectly square base and perfectly angled sides were not an aesthetic choice or display of technical prowess alone. They were a literal replication of Mot on Earth. A sloppy angle or a misaligned corner was not just an engineering flaw. It was a spiritual failure, a crack in the cosmic order that could jeopardize the king's journey and, by extension, the balance of the entire world. This helps explain the incredible effort expended on perfection. The labor was an act of worship, and the precision was the prayer. The very shape of the pyramid itself is deeply symbolic. Egyptologists point to the pyramid texts, the oldest known religious writings in the world, which were inscribed inside later pyramids. These spells describe the primordial mound, the first land that emerged from the waters of chaos at the dawn of creation. The pyramid, with its sharp, ascending edges, was a monumental recreation of this sacred hill. It was a piece of the moment of creation, frozen in stone, a place where the pharaoh could return to the beginning of time to be reborn. When you view the structure through this lens, the appearance of mathematical constants like pi and phi takes on a different meaning. They were not necessarily secrets the builders were trying to encode for the future. Instead, they were likely discovered as the inherent language of cosmic harmony. The builders, in their quest to create a geometrically perfect form that mirrored the order of the heavens, would have naturally stumbled upon these universal ratios. The pi relationship, achievable through their practical seeked system, produced the most stable and symbolically potent slope. The golden ratio, often found in nature's own growth patterns, would have been perceived as the most harmonious and therefore the most divine proportion. The precision was not anachronistic advanced science, it was the highest expression of their spiritual science. This interpretation offers a powerful resolution to our central mystery. It allows for intentional, brilliant design without requiring a lost civilization or extraterrestrial guidance. The Great Pyramid stands as a testament to a culture that saw the universe as a single, interconnected whole, where a perfect angle in stone was a direct conversation with the gods, and where building with mathematical certainty was the surest way to achieve immortality. The stone whispers its secrets to a new generation of listeners, armed not with chisels but with lasers. In the 21st century, our quest to understand the Great Pyramid has entered a new era. defined by technologies that can measure its every contour with millimeter precision. International scientific collaborations like the ambitious Scan Pyramids mission are deploying non-invasive techniques to see deep inside the massive stone blocks. One of the most revolutionary is muon tomography, which uses cosmic rays from outer space to create three-dimensional images of the pyramid's internal density, much like a medical CT scan for a building. This has already led to the stunning announcement of several large hidden voids, spaces within the structure that have been inaccessible for thousands of years. These anomalies are not merely hints of undiscovered treasure, they are profound architectural questions, challenging our very understanding of the pyramid's internal design and purpose. The investigation is no longer just about what we can see, but about what has remained deliberately or accidentally hidden from view for millennia. This technological leap allows us to test the legends with empirical data, moving from speculation to measurement. The goal is to verify with absolute certainty the exactness of the alignments and angles you have been considering. Just how perfect is that north-south orientation when measured by a satellite? How flawless are the corner angles when mapped by a drone's laser? The initial data is both confirming and confounding. It confirms the structure's staggering accuracy, validating the skill of its builders in a way that raw numbers alone never could. Yet it also challenges simplistic theories, revealing a complexity in the internal architecture that suggests the construction process may have been even more sophisticated than we supposed. This is not the end of the mystery, but a thrilling new beginning. The pyramid, it seems, is not yet finished with its revelations. Centuries after its construction, the Great Pyramid's silent geometry appears to whisper across the Mediterranean. There is no papyrus scroll or stone inscription that proves a direct link, yet the principles it embodies seem to reawaken in the minds of Greek philosophers. Pythagoras, who traveled to Egypt according to later traditions, would have encountered a culture deeply versed in the practical application of sacred geometry. While his famous theorem is a formal, proven statement, the underlying concept of harmonious numerical relationships governing physical forms was already a living reality in the stone masses of Giza. The pyramid stands as a monumental prelude to the idea that the universe could be understood through mathematics, a concept that would become the bedrock of Western science. This is not a claim of stolen knowledge, but rather a suggestion of a seed planted, a glimpse of a perfect form that may have inspired the pursuit of mathematical truth. We see this resonance again much later in the flourishing of the Renaissance. Architects like Leon Battista Alberti looked back to the classical ideals of Greece and Rome, championing proportions based on harmonic ratios. The Parthenon in Athens, though vastly different in style and function, is often analyzed for its use of the golden ratio in its facade, a proportion we find echoed in the Great Pyramid's own geometry. Was this a conscious echo of an ancient Egyptian ideal, transmitted through the classical world? Or is it evidence that human minds, when striving for perfect, timeless beauty, naturally converge upon the same mathematical foundations? The pyramid's form becomes a ghost in the machine of Western art and architecture, a persistent reminder that the most enduring human creations are often built upon a hidden framework of number and ratio. This potential lineage, however intangible, is a core part of its enduring fascination. It transforms the structure from a relic of a single culture into a foundational node in a sprawling network of human thought, its influence rippling through time not in written words, but in the silent language of shape and proportion that artists and builders have intuitively sought for millennia. This same search for meaning, however, can sometimes lead us astray, building intricate stories on foundations of sand. To truly appreciate the pyramid's authentic marvels, we must first clear away the modern myths that have accumulated around it like desert dust. One of the most persistent claims is that the Great Pyramid encodes the speed of light. The logic goes like this: if you take its geographic coordinates in degrees, 29.9792 degrees north, and you treat that number as a code, it is remarkably close to the scientific notation for the speed of light, 299,792 kilometers per second. The match seems miraculous, a number from the heart of modern physics hidden in an ancient location. But this is a classic case of a numerological coincidence, a pattern that emerges only through our modern systems of measurement. The ancient Egyptians did not use the decimal system or the metric system, which are the very tools that make this correlation possible. The kilometer itself is a unit defined in the 18th century based on a fraction of the distance from the equator to the North Pole, a measurement the Egyptians would not have used. Furthermore, the exact coordinate shifts slightly over millennia due to the slow tectonic drift of the Earth's crust, meaning the pyramid was not even at that precise latitude when it was built. We are connecting dots across time using a ruler that did not exist, creating a compelling but entirely accidental alignment. Another grand claim suggests the pyramid's dimensions contain a prophetic timeline of human history, with each inch representing a year, pinpointing world events from the birth of Christ to the world wars. This idea relies on a selective and often flexible interpretation of the structure's internal passages and chambers. Proponents will measure a specific corridor, find its length in pyramid inches, and declare that number corresponds to a significant year. The flaw here is that with so many corridors, niches, and angles to choose from, and with the freedom to decide where the timeline starts and stops, one can find a match for almost any important date. This is a demonstration of what statisticians call confirmation bias, where we actively look for and emphasize information that supports our existing belief while ignoring all the measurements that do not fit the pattern. If 100 different lengths are measured and only 2 align with known historical events, we tend to focus on those 2 striking hits and overlook the 98 misses. This is not evidence of prophecy, it is a testament to the human brain's incredible and sometimes misleading talent for finding patterns. These myth-busting exercises are not meant to diminish the pyramid's wonder, but to refine it. By applying the sharp tool of critical thinking, we separate the credible evidence from the fanciful speculation. This process actually empowers your own investigation. It asks you to question the source of a claim, to examine the units of measurement being used, and to consider whether a pattern could have emerged by pure chance given the vast number of possible comparisons. When we sweep away these exaggerated stories, we are not left with an empty site, far from it. We are left with the raw, genuine, and far more impressive mystery of how a Bronze Age culture, using the tools and knowledge we can verify they had, achieved such staggering feats of engineering and astronomy. The real puzzle is not about hidden codes for the future, but about the breathtaking limits of known human capability in the deep past. This disciplined focus on the plausible rather than the merely possible sharpens the ultimate question, compelling us to look at the one mathematical relationship that is so fundamental, so elegantly woven into the pyramid's very form, that it stands as the strongest candidate for intentional design. This relentless demand for precision was not just a spiritual pursuit, it was an overwhelming logistical reality. The sheer scale of the operation would have dwarfed any modern construction site, a continuous, deafening symphony of coordinated labor that stretched for over 20 years. Every single one of the estimated 2.3 million stone blocks, some weighing more than 2 adult elephants, had to be quarried, shaped, transported, and set into place with an accuracy that would challenge today's engineers. To achieve this, the project managers needed more than just a grand vision. They required a flawless system of industrial engineering, a level of organization that makes the idea of haphazard construction impossible. Think of the challenge of the foundation alone. The base of the pyramid covers over 13 acres, and its cornerstones were leveled to within less than an inch of perfect. Achieving this across such a vast area with simple tools like water-filled trenches and sighting rods was a monumental feat of surveying. This was not a matter of getting it close enough, it was a non-negotiable requirement. A single significant error in the foundation would have been magnified with every subsequent course of stone, leading to catastrophic failure long before the capstone was ever set. This foundational precision was the bedrock upon which everything else depended, a testament to a quality control regime that functioned on an unimaginable scale. The methods for lifting these colossal blocks to ever-increasing heights remain one of Egyptology's great debates. The prevailing theory involves a massive, spiraling ramp built from mud brick and rubble, snaking its way up the growing pyramid. Crews of workers would have hauled the stones on sledges, navigating the steep inclines. But here again, precision was paramount. The ramp's angle had to be carefully calculated. Too steep, and the load becomes impossible to pull. Too shallow, and the ramp becomes impractically long, consuming as much material as the pyramid itself. The logistics of feeding, housing, and managing the thousands of skilled workers and laborers involved points to a bureaucracy of staggering efficiency. This was not a disorganized mob, but a highly structured society operating with military-like discipline. Different crews were organized into teams with names like the Friends of Khufu or the Drunkards of Menkora, a human touch that hints at the pride and camaraderie necessary to sustain such an effort for a generation. The consistency of the stone blocks themselves is another silent marvel. While the core blocks are rough, the outer casing stones and the stones for the internal chambers were cut with astonishing accuracy. The joints between these massive blocks are so tight that a credit card cannot be slipped between them. This level of stone fitting requires more than skilled masons. It implies a standardized system of measurement and a method for ensuring that every single block met the same exacting specification, day after day, year after year. This entire breathtaking enterprise was fundamentally an exercise in applied mathematics. The architects were not just using numbers on papyrus, they were using geometry to calculate ramp angles, fractions to allocate rations, and arithmetic to track the progress of hundreds of thousands of stones. The project's very success depended on a deep, working understanding of ratios, angles, and volumes. When you see the pyramid in this light as the ultimate expression of a managed system, the presence of sophisticated mathematical concepts like pi and phi within its shape feels less like an anomaly and more like a natural extension of the same brilliantly mathematical mind that orchestrated its construction. The building itself is the proof of its designer's genius, a masterpiece of both thought and labor that stands as a silent testament to what humanity can achieve when intellect and will are united on a colossal scale. But the Great Pyramid's mathematical voice does not echo in a vacuum. When we widen our gaze across the ancient world, we find a chorus of other monuments speaking the same silent language of precision. Far to the north, on the windswept Salisbury Plain, stands Stonehenge. This ring of massive stones was positioned with such care that its central axis aligns with the rising sun on the summer solstice. The heel stone marks this celestial event with breathtaking accuracy, a feat that required generations of observation and a deep understanding of the sun's slow dance across the sky. Across the Atlantic, high in the Andes Mountains, the Incas constructed Machu Picchu. Here, the marvel is not celestial alignment but stone fitting. Enormous blocks of granite, some with more than 30 sides, were carved to interlock perfectly without a single drop of mortar. The joints are so tight that the structures have withstood centuries of earthquakes, their stones shifting and settling before clicking back into place, a testament to an almost organic understanding of geometry and material. In Cambodia, the Temple of Angkor Wat is laid out as a microcosm of the Hindu universe, its dimensions and bas-reliefs encoding astronomical cycles and units of time with a sophistication that still astounds researchers. These global examples present us with a critical question. Is the Great Pyramid a solitary, inexplicable miracle, or is it simply the most grand and perfectly preserved example of a shared, ancient capability? Each of these cultures, separated by vast oceans and with no evidence of contact, arrived at a similar conclusion that the highest purpose of architecture was to mirror the order of the cosmos through mathematical harmony and engineering perfection. They each discovered that to build for eternity, one must build in conversation with the immutable laws of nature and the heavens. This pattern suggests that the precision at Giza may not be an outlier, but rather the ultimate expression of a potential that existed wherever human ingenuity was driven by a deep, spiritual need to make the sacred tangible. The real mystery then deepens, not lessens. It shifts from asking how one culture achieved this to wondering why so many, in isolation, heard the same cosmic rhythm and learned to build its beat into stone. So where does this leave us, standing before this mountain of stone and meaning? The evidence of the Great Pyramid ultimately pushes past archaeology and into the realm of a much grander philosophical puzzle, one that has haunted human thought for centuries. We are confronted with a fundamental choice in how we interpret its existence. On one hand, we can view it as the magnificent endpoint of a long, slow process of trial and error, where gradual improvements in quarrying, logistics, and simple geometry culminated in this one perfect form. In this view, the appearance of pi and phi and the celestial alignments are beautiful accidents, the inevitable statistical outliers that occur when a culture builds on a colossal scale for long enough. This perspective sees human progress as a meandering river, slowly carving its path through the landscape of possibility. The other possibility is that the pyramid is exactly what it appears to be, the product of a brilliant designing intelligence. This is not necessarily a religious argument, but a philosophical one rooted in the concept of teleology, the idea that certain structures in nature and human creation show evidence of having been shaped for a purpose. From this vantage point, the convergence of so many precise mathematical and astronomical relationships in a single edifice is not a random fluke, but the clear signature of a mind that understood the deep laws of the universe and intentionally encoded them into a permanent physical form. The pyramid then becomes a powerful case study in a timeless debate. Does complex, integrated order emerge from chaos through mere iterative processes, or does it require a conscious plan? This artifact challenges our modern assumption that knowledge progresses in a neat, linear fashion, always accumulating and improving. What if instead human history is punctuated by flashes of transcendent genius, peaks of understanding that are later forgotten, leaving behind only enigmatic monuments as their proof? The pyramid does not give us an easy answer, but it forces us to clarify the question itself. It asks you to decide what you believe about the potential of the human mind and its relationship to the cosmos. Are we simply clever animals who stumbled upon perfection, or are we beings with an innate capacity to perceive and replicate the fundamental harmonies of existence? Your answer to that question will determine whether you see the Great Pyramid as history's most spectacular coincidence or its most profound and deliberate message. Beyond the grand constants of pi and phi lies a more intricate numerical landscape, one that speaks to a different kind of mystery, For those drawn to the allure of sacred numbers, the pyramid's internal architecture reveals a playground of potential patterns. The lengths of its ascending and descending passages, the precise dimensions of the king's and queen's chambers, all seem to hum with numerical significance when examined through this lens. A compelling example for many is the recurring appearance of the number 144, a figure often associated with sacred geometry. Some researchers note that various combinations of the pyramid's base and height in cubits can yield this number, connecting it to concepts of spiritual completion and cosmic cycles found in later traditions. The niche in the Queen's chamber, with its complex structure of 7 layers, is also sometimes analyzed for its potential encoding of astronomical cycles or units of time. This is the realm of gematria, where numbers are not just quantities but carriers of hidden meaning. It is a practice that finds resonance in many ancient cultures, where letters had numerical values and names could be decoded into significant sums. The appeal is undeniable, offering a tantalizing key to unlock what seems like a coded message from the past. Yet, this is precisely where we must apply our sharpest critical thinking. Mainstream scholarship urges a crucial distinction here between a meaningful mathematical constant and an arbitrary number game. A constant like pi is a universal ratio, a fundamental relationship that appears regardless of the unit of measurement you use, whether cubits or centimeters. The appearance of a number like 144, however, often depends entirely on the specific units and the particular mathematical operations one chooses to perform. With a structure as numerically rich as the Great Pyramid, it is statistically almost guaranteed that you can find many such numbers if you have the freedom to multiply, divide, and combine different measurements. This is not to dismiss the fascination, but to contextualize it. The pyramid, in its silent perfection, acts as a perfect mirror for our own desires to find meaning. It invites us to project our own numerical frameworks onto its stones, revealing as much about our search for patterns as it does about the builder's original intent. This foray into deeper numerology shows that the pyramid's true power may not be in a single, deciphered code, but in its limitless capacity to inspire wonder and interpretation across the centuries. Our modern measurements of the pyramid's near-perfect dimensions face a sobering reality. The structure we see today is a weathered core, a stripped and eroded skeleton of its original form. Centuries of natural forces and human activity have fundamentally altered its shape. The brilliant, smooth, white casing stones of polished Chura limestone that once sheathed its entire surface were pried away over the ages, often to build mosques and palaces in nearby Cairo. What remains is the rough inner core, exposed to the elements and visibly worn down. Even the very peak is different, the original capstone long gone, replaced by a small, rough platform. This physical degradation introduces a crucial element of uncertainty into all our precise calculations. How can we be sure of the original base length or the exact slope angle when the outer skin, which defined those precise lines, is almost entirely missing? Egyptologists address this by studying the few remaining casing stones still in place at the very base of the structure, particularly around the corners. They also examine the foundation sockets, the precise grooves cut into the bedrock that held the pyramid's first course of casing stones. By analyzing these precious clues, researchers can make educated estimates of the original dimensions, but these are still estimates. The original base perimeter is not a measurement we can take with a tape, but a figure we must carefully reconstruct. This is not a minor detail, it is the foundation of the entire debate. It reminds us that we are not analyzing a pristine, perfect geometric form, but interpreting a magnificent, damaged artifact. The incredible precision we discuss is in part a ghost of the pyramid's former self, a mathematical echo of a perfection that has long since been stripped away by time. This acknowledgement does not diminish the achievement, but rather grounds it in a more honest and fascinating reality, forcing us to wonder if the original, complete structure held even more secrets that are now lost to us forever. The challenge of making the first lines perfectly straight and the corners perfectly square on a 13-acre site seems almost impossible, yet the evidence points to a solution of elegant simplicity. To level the bedrock foundation, the Egyptians likely used a method as fundamental as water itself. They would have cut a grid of shallow trenches across the entire building site, then filled them with water. Because water always finds its own level, the surface of the water in every connected trench would be exactly the same height. By marking a consistent water line on the sides of the trenches and then cutting the protruding bedrock down to that line, they could create a perfectly level plane across the entire massive area. This was not high technology, but it was brilliantly effective, transforming an uneven limestone plateau into a flawless starting canvas using nothing more than gravity and observation. Creating perfect right angles for the corners presented a different kind of puzzle, one solved with a length of rope. The most plausible method involves the simple yet powerful geometric principle of the 3-4-5 triangle. If you take a long rope and tie 12 equally spaced knots along its length, you have a ready-made measuring tool. By having one worker hold the rope at the 3rd knot and another at the 7th knot, a third person can pull the 2 free ends taut. This forms a triangle with sides of 3, 4, and 5 units. The angle between the 3-unit and 4-unit sides will be a perfect 90 degrees. This reliable technique, a practical application of what would later be known as the Pythagorean theorem, would allow surveyors to establish the pyramid's first perfect corner. From that single right angle, they could then use more ropes to measure out the base lengths and establish the remaining 3 corners, creating the immense square that would dictate the entire structure's form. Achieving the mirror-smooth surfaces of the outer casing stones required another layer of meticulous craftsmanship. After the rough blocks were set, teams of stone finishers would have gone to work. They likely used harder stone tools like dolerite pounders to painstakingly chip away at the surface. The final, breathtaking polish was probably achieved by rubbing the stones with abrasive sands such as quartz and water, gradually grinding the limestone to a flat, reflective sheen. The true test of their work came at the very end. The final pyramidion capstone was likely set in place first, before the upper casing stones were installed around it. This meant the teams had to work their way down, ensuring each massive, polished block fit perfectly against its neighbors as they descended. This top-down method guaranteed that the final, lowest course of casing stones locked into the foundation with absolute precision, presenting the world with a seamless, geometric mountain that reflected the sun with blinding brilliance. These methods prove that the pyramid's perfection was not born from magic, but from the disciplined application of simple, powerful principles repeated with unwavering accuracy millions of times over. But the Great Pyramid was never meant to stand alone. Its true meaning emerges only when we pull back to see it as the centerpiece of an entire sacred city of the dead. The Giza Plateau is a meticulously orchestrated complex with the 3 great pyramids, the enigmatic Sphinx, and a network of causeways and valley temples all arranged in a precise, interlocking layout. This grand design suggests the architects were thinking on a scale far beyond a single tomb, planning a landscape that would serve as an eternal, functioning machine for the afterlife. The spatial relationships here are anything but random. The southeast corners of the 2 larger pyramids, Khufu and Khafre, align along a perfect diagonal, a feat of surveying that required astonishing foresight and control over this vast terrain. Some researchers propose that the very positions of the three main pyramids were laid out to mirror the three stars of Orion's belt, with the Nile River representing the Milky Way, physically grounding the pharaoh's celestial destiny in the very soil of Egypt. This idea extends beyond stars to the geometry of the land itself. When you connect the centers of the three pyramids, the resulting triangle displays remarkable mathematical properties, with angles and side ratios that some analysts argue reflect fundamental geometric principles. The placement of the Sphinx, gazing eternally toward the rising sun, adds another layer of cosmic alignment to this grand scheme. It is as if the entire plateau was conceived as a single, unified instrument, calibrated to harmonize with the cycles of the heavens. This holistic vision transforms our understanding of the Great Pyramid's precision. Its perfect angles and alignments are not isolated marvels, but integral components of a much larger, coherent blueprint. The sheer logistical feat of coordinating the construction of multiple pyramids, temples, and monuments over generations points to a sustained, centralized vision, a master plan passed down through reigns. This grand, unified design makes the argument for random chance seem even more fragile. Could such a complex, interwoven arrangement of colossal structures, each demonstrating individual precision, really be the product of disconnected, sequential projects? Or does the Giza complex stand as the ultimate testament to a civilization that could envision and execute a sacred geography, weaving stone, sky, and earth into a single, enduring testament to their cosmic order? This ancient structure taps into something far deeper than historical curiosity. It confronts us with what psychologists call an insoluble problem, a puzzle that resists any easy, comfortable answer. Our minds are wired to seek patterns and resolve uncertainty, yet here stands a monument that defies our established timeline of human progress, creating a cognitive itch we feel compelled to scratch. The sheer scale of the pyramid, combined with its immense age and the haunting suggestion of knowledge it should not possess, forms a perfect trap for the human imagination. It becomes a vast, silent screen onto which every generation can project its own deepest questions about civilization, technology, and our own forgotten potential. We are drawn to the gaps in the story, the empty spaces in the historical record that our minds instinctively rush to fill. This explains the powerful emotional divide between the cautious academic and the passionate speculator. For the scholar, the mystery is a complex equation to be solved with careful evidence. For the public, it is a legend in the making, a story that challenges the very foundations of what we believe is possible. The pyramid does not merely belong to ancient Egypt, it belongs to everyone who has ever looked at it and felt a sense of awe, a whisper that there is more to our story than what is written in the textbooks. Its enduring power may not be locked in its stone alone, but in its unique ability to make us feel, for a moment, both wonderfully small and connected to a mystery that spans the ages. So the scales are set before us. On one side, we place the argument for coincidence. This view asks us to accept that a civilization, through practical trial and error, achieved a series of stunning mathematical and astronomical alignments without consciously intending to. The pi ratio emerges from a simple, repeatable building slope. The golden ratio is a natural byproduct of a stable, aesthetically pleasing form. The celestial alignments are expressions of deeply held religious beliefs, not a precise star map. And the geodetic correlations are statistical flukes, the inevitable result of testing countless numerical combinations against a structure with so many measurements. This explanation is elegant in its simplicity. It requires no lost civilizations, no advanced secrets, just the gradual perfection of known techniques on a monumental scale. It is the path of least assumption. On the other side rests the case for deliberate design. Here, the sheer number of precise and interconnected relationships becomes the central fact. It is not just one alignment, but the convergence of them all within a single, coherent structure. The pi and phi constants, the near-perfect cardinal orientation, the targeted star shafts, and the potential modeling of Earth's dimensions together, they form a pattern so intricate it seems to defy random chance. This perspective argues that such an integrated tapestry of universal constants points to a conscious, designing intelligence, an architect who understood the deep language of the cosmos and sought to immortalize it in stone. So how do we judge which explanation carries more weight? One guiding principle is inference to the best explanation. Which narrative more fully accounts for the entire body of evidence before us? Does the coincidence theory adequately explain why so many fundamental constants appear together so elegantly? Or does the design theory better illuminate the breathtaking harmony between the pyramid's geometry, its placement on the Earth, and its alignment with the heavens? There is no final, objective verdict handed down to us. The evidence does not compel a single answer. Instead, it invites a personal conclusion based on how you interpret the balance of probabilities. Do you see a masterpiece of human ingenuity where perfection emerged gradually from practical need? Or do you see a calculated, intellectual blueprint, a message in stone meant to encode the very principles of the universe? The stones have given you their data. The choice of what it means is now yours. We have journeyed through the numbers, the stars, and the stones, weighing the evidence for a design of cosmic intelligence against the possibility of a magnificent, accumulated accident. The scales never quite settle. On one side, the sheer convergence of pi and phi, the celestial alignments, and the geodetic hints form a tapestry of interlocking precision that feels too coherent to be random. On the other, the practical genius of the sect, the power of cultural symbolism, and the sobering reality of statistical pattern seeking offer a grounded, human-scale explanation. This is not a puzzle with a missing piece, but a mirror reflecting our own assumptions about history. The Great Pyramid ultimately challenges a comfortable narrative of linear human progress, whispering that flashes of transcendent genius can appear, shine brilliantly, and then be lost to time, leaving only a silent stone question behind. A modern physicist once reflected that the greatest mystery is not that the pyramid was built, but that we are still unraveling its secrets millennia later. This enduring enigma speaks to something timeless within the human spirit, our relentless drive to understand our place in the cosmos and the legacy of those who came before. So where does your interpretation land after this exploration? Do you see the hand of deliberate, lost knowledge, or the pinnacle of known human skill amplified by chance? The stones have presented their evidence. The final verdict is yours to share. Thank you for joining this investigation into one of history's most profound wonders. If this journey into the deep past has intrigued you, consider subscribing for more explorations into the enigmas that shape our world.